You made it to halfway through Unit 6, 6.5, which is simplifying rational expressions. Our objective today is that students will be able to simplify rational expressions. So really quick, let's do some review. Recall that when we multiply fractions, we can simplify the numerators and denominators. So simplify the numerical fraction 18 over 6 by first expressing it as a product of two fractions, one of which is equal to 1. So this is another way of saying I want to break my numerator down to prime numbers and I want to break my denominator to prime numbers. And I teach you the trick where on the calculator you can just enter FACTOR parentheses 18, and it breaks 18 down, which is 3 times 6. Do the same thing for 12, and it will be broken down as 2 times 6. The 6 are cancels off, and you get 3 over 2. So that's my fraction in simplest form. Now what about B? At the top, that's a difference of square. Remember when you take the square root of 9? So in the top, I have x minus 3 and x plus 3 over, look at the bottom, 2x plus 6. They have a 2 in common, and I'm left with x plus 3. So how do you check what does 2 and 6 have in common? You can, and I'll make a little note, GCD 2 comma 6. It should tell you a 2 in common. Now what happens? These are cancels off. The x plus 3's at the top and the bottom. They're the same. I can cancel off. And I'm left with x minus 3 over 2. And this is my rational expression in the simplest form. Now it says every time we simplify a fraction, we are essentially finding all common factors of the numerator, my top number, and denominator, my bottom number, and dividing them to be equal to 1. The key process is that the numerator and denominator must be factored, and only factors can cancel each other, meaning here the 6 on top, the 6 at the bottom cancel, and the x plus 3 in the top and the x plus 3 in the bottom cancel as well. This is true whether our fraction contains a monomial, binomial, or any polynomial expressions. So moving along, let's look at, remember this rule, when I'm dividing same base, what do I do with the exponent? I subtract them. So let's look at some examples. So 3 over 6, we're going to take it piece by piece. 3 over 6, that's 1/3. And then the same base, so I want to do x 5 take away 8, and then y 6 take away 3. This actually works out to be 1 over 3, x to the negative 3, y to the positive 3. But remember, when we were reviewing the finals, we talked about we don't ever want to see a negative exponent. So what do? We flip it to the bottom. So this becomes, remember, this is the same thing as over 1 over 1, if you want to think of it that way. So these are all in my numerator. So I'm going to flip this to the bottom. What's left on top? Y third over x 3x to the third. So I want you to think of these as over 1. And then I'm just flipping that to the bottom. The 3 is my denominator, so it stays there. This becomes my final answer. Let's take a look at this one. 20 divided by 4, we know that's 5. Then I have x, 10 take away 2, and then y, 8. This becomes 5, x to the 8, y, 8. All my exponents are positive, so this is my final answer. So let's keep it going with C. 7 over 21. So again, this is 7 over 21 is 1 over 3. If you're not sure, enter 7 over 21 and hit enter on the calculator, and it will tell you. On a side note, now let's write this out. This is x 3 take away 5 and y 1 take away 8. Remember, that's an invisible 1. So I'm left with 1 over 3. This becomes x to the negative 2 and then y to the negative 7. So remember, these are the same thing as I have divided by 1. Remember, another way of writing 3, right? If I say write 3 as a fraction, you would tell me that is 3 over 1. So this is the same thing. So think of it as this x to the negative 2 and y to the negative 7 are all in my numerator. We don't want a negative exponent, so the way I get rid of that negative is just flipping it to the bottom. So I'm going to move x to the negative 2 in the bottom, y to the negative 7 to the bottom, so the only thing that's left in the top is 1. I had my 3 in the bottom. This becomes x squared, y to the 7. Final answer. Moving along. This is how you see this on the regions. Which of the following is equivalent to blank? Now 10 over 15 is the same thing as both of these have a 5 in common. So 2/3. This becomes x 6 minus 2 and then y is 3 minus 6. So we have 2 over 3, x to the 4th, y to the negative 3. Now remember what we said, no negative exponents, so we're going to be left with 2x to the 4th over 3y to the 3rd, which is choice number what? 2x to the 4th, y to the 3, choice number 3. So a tip for you, when simplifying rational expressions that are more complex, more difficult, always factor first, then identify the common factors that can be canceled. So we're going to talk about some more complex rational expression here. 1, 2, 3 examples. So this goes back to unit 2 and 3 when we're doing differences square, when we're factoring quadratics, when a is 1, when a is negative 1. See why we needed to master these now? So let's look at the first example. So I'm going to call this 1 and this is going to be 2. We have to factor each of these part, my numerator and my denominator, and then look for what they have in common. So the first part, let's do this as number 1. X squared plus 5x minus 14. My a is 1, my b is 5, my c is negative 14. My x method, negative 14 on the top and positive 5 in the bottom. Two numbers would be 7 times negative 2. Because a is 1, my new top, I can just write this as x plus 7 and x minus 2. So the top, my numerator, is actually going to be x plus 7 and x minus 2. Now we need to work on the bottom part of it. So let's do a different color. So let's call the bottom 2. So for bottom, it's x squared minus 4. There's no middle term, and if 4 is a perfect square, so I know this is a difference of square where I can do x minus 2 and x plus 2. So the bottom end up being x minus 2, x plus 2. Then I'm going to look for what do they have in common. Is there any factor that they have in common? They both have an x minus 2 and an x minus 2. Those are canceled, and then my final answer would be an x plus 7 and x plus 2, which is my leftover 2 factors. Sorry. Alrighty? So again, when we're doing these complex rational expression, I factor the top, which is in red. That's factoring a quadratic. And then I factor the bottom, which is in green. That's a difference of square. After I factor these, I look for the common factor, which is x minus 2. There's an x minus 2 at the top and an x minus 2 on the bottom, so I can cancel that. And then I'm left with the remainder, which is x plus 7 and x plus 2. Go ahead and copy that because I'm going to be erasing those out. So take a minute, pause the video, and copy that. So now that you copy that, let's get rid of that and we're going to work on B together. So again, B, let's do the top. 4x squared minus 1. I know 4 is a perfect square, so this is actually a difference of square, which is 2x minus 1 and 2x plus 1. So this becomes the 2x minus 1 and 2x plus 1. Here we go. Over. Now, what's the bottom? So let's call this, we said this is 1, let's do 2. 10x minus 5. This is not a quadratic because it doesn't have the square, but they do have something in common, which is a 5. Taking a 5 out, 5 times 2 will give me 10, and x is left over, minus 5 times what will give me 5 is a 1. So the bottom actually works out to be 5 parentheses 2x minus 1. Now is where I look. What do these have in common? They have a 2x minus 1 in common, which I cancel. And then what's left over? 2x plus 1 over 5. And this is my rational expression simplified. See? You just have to be able to identify, how can I factor this? Is it a quadratic? Is it just something that has a greatest common factor? That's why we worked on this so much in Unit 2 and 3. So again, pause the video, finish copying this because I need to take this out so we can work on C. Alrighty, so you got this down on your paper. Let's get rid of this. And we are going to start with C. Now C, we're going to start with the first part. And I'm going to come all the way over here. 3x squared plus 14x plus 8. My A is 3, my B is 14, and my C is 8. Make my x 8 times 3 is 24, and 14 on the bottom. So two numbers are multiplied to give you 24 and add to give you 14. Those numbers are 12 and 2. Now A is bigger than 1, so this is where we have to do that special thing in replacing my B term. So this now becomes 3x squared plus 12x plus 2x plus 8. I take the first two term and the last two term. What do these have in common? 3x, x plus 4. And again, you should master this from Unit 2 and 3. X plus 4. These are the same, so I write it back once. And then my two factors that I pulled out becomes 2x plus 3x, plus 2. So, for this now, my numerator becomes x plus 4 and 3x plus 2 over, now the bottom, let's call this number 2 right here, is x squared minus 16, which we all know is a difference of square. So take the square root of this. We get x squared minus 4 squared, and then we can write this as x minus 4 and x plus 4. So my denominator, becomes x minus 4 and x plus 4. Now that I factor my numerator and my denominator, is there any factor in common? Yep. They both have an x plus 4 and an x plus 4. So then what's left over is the 3x plus 2 over the x minus 4. That's my final answer. There you go. Moving on to the last exercise for today is, there's a special type of simplifying that occurs when the expressions are in the form of x minus y and y minus x, meaning they're flipped. But let's see what really happens with such numbers when they're flipped. So in this case, 9 minus 6 and 6 minus 9. So let's just simplify this. 9 minus 6 is 3. And then 6 minus 9 is negative 3. 3 divided by a negative 3 is a negative 1. That's my final answer. What about this here? 15 take away 3 is 12. And then 3 take away 15 is negative 12, which also give me a negative 1. Let's see if it holds for this. Alright, so the last one. A minus B over B minus A. So I want this where I can have the top as a positive B, so I can just cancel this off. So I know the bottom is going to be this. I want to know how can I make this B a positive and the A a negative. So I want this to be negative A plus B, which are the same thing. How can I go from a negative B to a positive B is multiplying it by a negative 1. This is the same exact thing as me writing negative 1 B minus A over B minus A. In this case, I have two beautiful factors that I can cancel, and then what is left over? My negative 1. So whenever we have x minus y or y minus x, when they're flipped, the answer will always be a negative 1. To finish our lesson today, I added 2 regions question to exercise 6 and 7. Let's see how this works. Which of the following is equivalent to 2x minus 10 and 25 minus x squared? So we're going to factor the top. It's not a quadratic. They have a 2 in common, so this becomes a 2 parentheses x minus 5 over, take the square root of this, so we get 5 minus x and 5 plus x. So let's get rid of this because I need some space. Now, is there any factor in common? No, they're not. See, it says x minus 5, but here it says 5 minus x. So this is where it gets a little tricky. How can I make this here, x minus 5, to match 5 minus x? So I know that the bottom is going to be the same, 5 minus x and 5 plus x. I want to make the top to have it as minus x plus 5, which would make these two here cancel off. How can I do that? Now if I multiply by a negative, remember up here that I just erased, I multiplied this by a negative in order to get back there. So now, since there is a 2 out here, all I need to do is make this 2 negative. And just to show you that this works, is if I was to distribute this over, I'm going to get 2x plus 10, which is 2x minus 10, sorry, a negative times a negative times a positive is a negative. So this will be 2x minus 10, which is what I started with up here. Now these two cancel off, or you can rewrite this as negative 2, 5 minus x, whichever you feel comfortable with is fine. 5 plus 10. Now these are cancel, and you're left with negative 2 on the top and 5 plus x at the bottom, which is choice 1. Alrighty, last example goes, which of the following is equivalent to this? Now look at the top. Break this down. X squared minus 6x plus 9. A is 1. B is negative 6. C is 9. 9, negative 6. So I know this is going to be a negative 3 and a negative 3. So the top is actually x minus 3 and x minus 3. What about the bottom? Break the bottom down. 18 minus 6x. They have a 6 in common, so it's 3 minus x. So here we go. The top is x minus 3 and x minus 3 over 6, 3 minus x. That's not a k, that's an x. So now, again, how can I make these two equals the same thing. So multiply by a -1. This becomes a 3 minus x and x minus 3. Remember, we proved, like, if we switch, if I was to switch, remember your x minus y, and if I had y minus x, when I multiply this, it will be a -1, the difference from our example in the top here. It will be a -1 when I divide them. Forgot my division side. So that's why if I do a -1, I can simply just switch these. When I switch them, this is cancel and this is cancel out. And what am I left with on top? -1 x minus 3 over 6. Just distribute this over, it becomes -x plus 3 over 6. Or you can write it as 3 minus x over 6. So these are the two, this is the answer. One of this will be in your answer choice. So let's see which one it is. We have -x plus 3. We don't see that. Or another way of writing it is 3 minus x over 6, which is choice 4. Oops. So I know this is a long lesson because of a lot of factoring, but I know that you can do this, guys. Come on. We're on Unit 6. You made it this far. Good luck.